Akansh. Yeah. Welcome to Aksharanan classes. This is Gafar sir, your physics faculty. Let's start our session. Yeah, actually we done with fluid chapter. Am I right? Pressure fluids chapter. We explained Pascal's law as well as Archimedes principle, right? So and we have derived the expression for a buoyancy force acting on the object by using the Archimedes principle, isn't it? Now this is actually that is the that is the chapter end. Understand? We have to do some problems, but before the problems, I'll start a new chapter. Okay. At a time I will do answers the questions based on the chapter. Okay, na? Now the last and final chapter is, what is the last and final chapter? Wave and sound. Wave motion and sound. Understand? Wave motion and sound. Wave motion and sound is the last and final chapter. So let's talk about first wave and what is the relation between this wave and sound. Let us discuss. Now here the thing is, wave is nothing but it is a disturbance in the medium. Wave is nothing but disturbance in the medium. So what going to be happened with this wave? This wave is it is transporting the energy and momentum from one position to other position without changing the object or without changing the mass. Got my point? Generally, here energy and momentum, those are the two physical quantities. To move the physical quantities or to explore the physical quantities from one place to other place, we require particle motion generally. For example, this is an object having mass m. If this is having velocity, when this is having velocity, it possesses what kind of energy? It possesses kinetic energy, because the moving bodies possess kinetic energy, and the moving bodies also having momentum. Okay, so when this mass is moves, then we can say the energy transformation. In that case, the energy will transfer. In the case of wave, without changing the position of this mass, without changing any disturbance of the mass, we can shift the energy from one place to other place. That is the significance of the wave. Got my point? We can shift the energy from one place to other place. We can move the energy one place to other place without changing the position of the particle, without changing the position of the mass, is known as a wave. Got my point? So what we can conclude about wave? Wave is a disturbance in the medium. It can it can transport the energy and momentum one place to other place without changing the particle position. Got my point? So this is what wave, kind of wave. And next we have, based on the motion of the particles, based on the disturbances, we derived we have some types of the waves. Understand? Generally, again I am repeating what is wave. The wave is a disturbance created by the particle vibration. Okay, wave is a disturbance created by the particle vibration, and it is transporting the energy from one place to other place. This is known as a wave. And now let's see the types of wave. Types of wave. So very important, this is types of wave. This is a very important, because the types of wave based on something, would be different. First of all, based on particle vibration. Based on particle vibration, the wave divided in two types. Generally, just now I explained that wave is produced from vibration of the particle in the medium. Am I right? The wave is produced from in the medium because of the vibration of the particle. Now here, based on the vibration of the particle, again we have two types of the waves. Very first one is transverse wave. Second one is longitudinal wave. First one is what? Transverse wave. Second one is what? Longitudinal wave. What is this transverse wave and what is this longitudinal wave? Let's see now. The transverse wave means, the wave is produced because of the vibration of the particle. Now, if the vibration of the particle is in the direction, in the perpendicular direction of the wave propagation, the kind of wave is known as transverse wave. Once again, I am repeating, the wave is producing because of the vibration of the particle. These vibration happen perpendicular to the wave propagation. The kind of wave is known as transverse wave. Let me take, this is a particle. This particle is now, due to vibration of this particle, the wave is producing as this way. This is the way the wave is producing. Wait, let me write here. This is a particle. Now this is the wave because of the vibration of the particle. But here the vibration happen in which direction? Through and for motion perpendicular to the wave propagation. This is the wave propagation and the particle is vibrating this way, through and for motion, up and down, but the motion of the wave is forward direction, but the particle is vibrating up and down. So that this kind of wave is known as what? Transverse wave. Alright. The next thing is longitudinal wave. What is this longitudinal wave? Again, this is a particle. This is a particle, and due to this particle, the particle is now vibrating. The particle is vibrating. When the particle is vibrating, this way you are having the wave. This way you are having the wave, and this is a wave motion. When the wave is moving in this direction, but the particle is vibrating. The particle is vibrating in which direction? In this direction. This way. Okay? This way, along the direction of the propagation, if the particle is vibrates, the kind of wave is known as what? What kind of wave? It is longitudinal wave. Here this is transverse wave. Now, explanation is very easy. Explanation is very easy, but finding the examples are more important than explanation. Understand? Finding the examples. What is the example for transverse wave? What is the example for longitudinal wave? See, I will tell one example for transverse wave. You know water wave? When a pebble is dropped in silently, a calm water, what going to be happen? You will observe some vibrations. You will observe some waves. But observe any one of the particle of the water wave, any particle, the particle is vibrating up and down. Am I right? Yes, sir. But the wave propagating in forward direction. The wave propagating in forward direction, the particle is moving up and down, which means that the wave is known as what kind of wave? Water wave is known as what kind of wave? Transverse wave. Because the particles are vibrating perpendicular to the wave propagation. Perpendicular to the wave propagation, since it is a what kind of wave? Transverse wave. And coming to the longitudinal wave. Let me take a silky. You know what is meant by silky? The spring. You know the springs, spiral springs. You play with that silky. If you jerk the silky, what going to be happen? All the particles will move, or all the particles vibrate in the direction of the wave propagation. So that is the one of the example for what? Longitudinal wave. Even sound also wave, the sound wave also longitudinal wave, because in the sound wave, the particle will vibrate in the direction of the wave propagation. Since the sound wave is also what kind of wave? Longitudinal wave. Then one more example for transverse. One more example for transverse is what is that? EM wave. EM wave also one more example for what? Transverse wave. Water wave also one more example for what? Transverse wave. Coming to the longitudinal, the sound wave is example for longitudinal, and one more is what? Vibration happened in the silky also is example for what? Longitudinal wave. Understand? And coming to the other part. So this way we have divided based on what? Based on what? Vibration of what? Vibration of what? Vibration of the particle. Now let me go for second one. Now based on the medium of propagation. One more type is what? Based on medium of propagation. Based on medium of propagation. See, let us take the first one. Based on medium of propagation, we have two types of waves. One is mechanical wave. Mechanical wave. Second one is, tell me. Transverse wave. Mechanical wave, and second one is what? Transverse wave. So now, what is this mechanical wave? Tell me the mechanical wave. So look at here. Any medium, any wave is required. Any wave is required a medium to propagate. The kind of wave is known as what? Mechanical wave. Look at, write on here. Any medium. Write on the definition for mechanical wave. Definition for mechanical wave. Mechanical wave. So first one is what? Any medium required. Any medium required. Sorry, any wave required. Sorry, any wave required to propagate. Any wave required medium to propagate. Any medium required to propagate is known as tell me, is known as what kind of wave? Mechanical wave. Very good. Now I want examples. Examples for mechanical wave. Example: any medium required. Any wave required a medium. Any wave required a medium. For example, sound. To propagate the sound, is it required the medium or not?
Yes, sir.
Since it is a what kind of wave? Sound wave is a mechanical wave. Even let me take a wire. Okay, one end it is fixed, another end is it is in my hand. Now give a jerk to the wire. Then what happened? It will produce some wave, isn't it? So when it is producing some wave, to get that wave, is that wire medium is required or not? Since that kind of wave also what? What kind of wave? Mechanical wave. Even water wave also what kind of wave? Mechanical wave. If the water is not present, will you get the water wave? The wave is producing? No, not producing. Since the water wave also what kind of wave? Mechanical wave. And the next same way, give me another example. Give me one more thing. What is that one more thing? Non-mechanical wave. What is this non-mechanical wave? What is this non-mechanical wave? Any wave not required medium. Any wave not required medium to propagate. Any wave not required to propagate is known as what kind of wave? Is known as what kind of wave?
Transversal is it, sir?
Is known as non-mechanical wave. Non-mechanical wave.
Sir, can you show the previous slide, sir?
What is the previous line? Any wave not required. You want previous lines? This is the previous line.
Next one. This one you have.
This is the next one. Based on the medium of propagation. So we have two types. One is what? Mechanical wave. One more is what? Non-mechanical wave. What is mean by non-mechanical wave? What is mean by non-mechanical? Any wave not required a medium to propagate is known as non-mechanical wave. Example. I want example. The example is, tell me the example. Non-mechanical wave. You know, light is a form of wave, kada? Yes or no? When the light is a form of wave, between the earth and the sun, from the sun we are having the light, kada? When you are having the light, so the thing is, non-mechanical wave. What is mean by non-mechanical wave? Any wave not required a medium to propagate is known as what? Non-mechanical wave. Example for non-mechanical wave is what? Between the earth and sun, we don't have any medium. When you don't have medium, even though light is reaching to us, which means that light wave is what kind of wave? Non-mechanical wave. Even light wave also known as a electromagnetic wave. Simply you can write here electromagnetic wave. Magnetic wave. Shortly we can call it as EM wave. EM wave not required any medium to propagate from one position to other position. Understand? And the thing is, one more final example. Finally, one more thing is what? Based on the propagation. Based on propagation. Based on propagation, again we have two types of the waves. First one is progressive wave. So progressive wave. What is meant by progressive wave? The progressive wave is a wave. It can't reach its initial position. Understand? What is a progressive wave? Progressive wave is a wave. It is not reached its initial position, its source. For example, in a pond, a calm pond or calm water, if you put a drop or else a stone, what will happen? You will get some waves. Am I right? Is that wave reaches its initial position? No, it can't reach. Since we can say that the water wave, we can call it as a what kind of wave? Progressive wave. It's the waves cannot reach its original position. Is known as what kind of wave? Progressive wave. Next thing is, so write down here the statement. The wave cannot reach its original position. The wave cannot reach its original position is known as what? Progressive wave. Similar way, next stationary wave. Stationary wave. What is a stationary wave? See, this is the wave it cannot reach its original position. Understand? Means it is not having end. Continuously it is propagating the medium until the energy lose. Until the energy loosed by the wave, continuously it will propagate in the medium. But what about this stationary wave? Stationary wave is a wave. What happens? It will reach frequently. It will reach periodically. It will reach its original position. The kind of wave is known as a stationary wave. It is a wave. So better write down. It is a wave. It can reach. Its original position. It can reach its original position in a periodic interval. In a periodic interval. Interval is known as what kind of wave? Stationary wave. Stationary wave. Example, I want example. So, right. So we are talking about what? We are talking about stationary wave. In the stationary wave, so what is happening in the stationary wave? The wave is transporting or wave is propagating between the two points is known as stationary wave. And in this case, what happened? The energy is what we can say? The energy is only moving between these 2 points. Okay, which means the energy is trapped here. Between these 2 points, the energy is trapped. So that kind of wave is known as what? Stationary wave. But in this, whereas in the case of progressive wave, the energy is transporting unless the total energy get lost, isn't it? So that kind of wave is known as progressive wave. But in the case of stationary wave, the energy is trapped between the points. So the wave is known as stationary wave. But the thing is, observe, here this way we have discussed that many types. How many types? First one is based on the particle vibration. We have what kind of wave? Transverse and longitudinal. And based on the medium of propagation, we have 2 types, mechanical wave and non-mechanical. But observe one thing. See, observe one thing. I want to say here, look at here, based on the medium of propagation, transverse wave. So I am writing all the waves here. Transverse wave, transverse wave. Next one is what? Transverse wave, longitudinal wave. And next one is what? Next one is what? Mechanical wave and non-mechanical wave. Next, another type, progressive and stationary wave, progressive wave and stationary wave. Now see common things here, common points. Any wave transverse and mechanical. Example, I want a wave must be a transverse and mechanical. Tell me what kind of wave it is? A wave, mechanical as well as transverse. So can you tell me, guess what is the example? A wave must be transverse and mechanical. So very good. Water wave. Water wave is a wave, transverse, mechanical, and even that is a progressive wave also, isn't it? Similar way, any wave transverse and non-mechanical. Transverse as well as non-mechanical, which means these 2. Before this type is what? Water wave. Now transverse, non-mechanical. Tell me example for transverse, non-mechanical. transverse and non-mechanical. The transverse and non-mechanical is, which means that the medium particles are vibrating perpendicular to the propagation, as well as it not requires any medium. What is the good example? Good example is electromagnetic wave, EM wave. EM wave, in the EM wave actually we don't have a particle, but here fields due to the vibration of the fields we are having the waves, but the vibration of the fields are vibrating perpendicular to the wave propagation. So that kind of wave is known as transverse wave. So the EM wave is not required any medium to propagate from one position to other position, since the EM wave is known as what kind of wave? Transverse and non-mechanical. Similar way, coming to the longitudinal. A wave is a longitudinal as well as mechanical. A wave, longitudinal as well as mechanical. What is the example? Sound wave, very good. Sound wave is a good example for what? Longitudinal and mechanical. Understand? Similar way, a wave, longitudinal as well as non-mechanical. A wave, longitudinal as well as non-mechanical wave. Tell me the example.
Sunrise.
Not sunrise. We don't have, still I did not find the example for this. You can search on your own. Okay, till now I did not find the example for what? Longitudinal and non-mechanical. Real, it has happened. So you can search on your own and tell me to me if you find any way the kind of wave, please inform me. Let me know. Okay. Notice. Light wave is a transfer wave, because light is a what kind of wave? Electromagnetic wave. Kada? Since light is a transverse and non-mechanical. Okay, this is how the example for what? Transverse wave, longitudinal wave, and combination of transverse wave and mechanical waves. Isn't it? Got clarity? But this is all about what? The types of waves and wave propagation. Now, let me go to the actual topic, that is sound. Now tell me, the sound is a what kind of wave? Sound is a what kind of wave? Sound is a longitudinal and what? Mechanical. Sound is a longitudinal, mechanical. So sound is a form of wave. Since sound is a what is this sound? Sound is a form of energy also. Sound is a form of energy, and it is traveling in the medium as a wave form. When it's traveling in the medium as a wave form, which means that energy is transporting from one medium to other medium. Since we can say that sound is a what kind of wave? Sound is a longitudinal and mechanical, and it is propagating the energy from one position to other position without changing the position of the particle. But the particles are vibrating in which direction? As a through and from motion. Isn't it? Isn't it? So this is what today's topic. In the next class we'll discuss the sound chapter. So only some little part is there for sound chapter, the terminology of the sound and how sound is propagating in the medium. That part only you have. More than that you don't have. So in the next class we'll complete that thing. Okay na? For today we'll stop the session. Bye.